What's up guys? In today's video, I'm going to take you through the process of actually making a billet part on one of our CNC machines. Of course, the raw material to the finished product. So let's get into it. So right here, we've got a solid block of aluminum, 6061 billet. We run off one in our VF4 and it leaves it like that. This part then gets flipped over into the VF2. When it's done, it comes out looking like that. So I'm gonna walk you guys through the steps of actually loading the part, tightening it, torquing it, probing it, and all the fun stuff, and then running it. So let's check it out. All right, so let's jump back into Fusion 360. Here's a cool view of the swing arm. I'm actually unclicking components and we're gonna focus on the main tube. Well, like I said, it all starts with the raw material. So we use USA sourced material from a local supplier in Arizona. They ship it to us on a pallet. We then break it down and we run it. So currently we're running this stack right here. This is the long side of our swing arm, and then this stack would be the short side. So every time we have a different piece, they all come in different shapes and sizes. We basically saw cut them to the exact length that we need. And again, all of our parts are gonna come in different widths, different lengths, and different heights. So this right here, for example, would be a triple clamp block. All right, Shane.
How you doing? All right, so for my first step, I'm gonna grab a block. We're gonna go over to the machine, inspect your jaws. If there's any chips, get your blow gun. Go ahead and blow the chips out of the jaws. To ensure your surface is smooth, you can set your part in. I like to move it back and forth, make sure it's good and tight. We're going to grab our stick out tool. You want to bump your part over, make sure it's pushed all the way back. So on this, you're going to tighten them down snug. I always like to look under the part to ensure that it's sitting flush all the way across. Take your hammer and you want to give it a good pop right over the vise towards the center. And then I always check and make sure there's nothing obstructing the door.
Let's talk about our little mud flap here.
Yeah, it's the seals wore out on the pan and we put the mud flap in to keep the chips from getting on the pan.
One problem you're going to have with the hoses, right on that seal wiper, right on that wiper right there, the chips will actually get stuck under it. Now, machining is pretty much mostly chip control. A lot of chips. Alright.
The door shut. Go ahead and hit the green button. On this one we have to hit F2 to cut our fan on. Always keep your finger on the red button until you know everything's going good.
Alright, so let's get going with op 1. We're going to get the roughing tool. Now this is going to go around the outside of the part. This is actually going to have a stock leave of about 8 thou. We do that so that we can go back with the finish tool and clean it up after. So we want to use a rougher to remove as much material as possible. And you guys can see the finish passes that are happening now. Now we're doing the face mill, some drilling, and of course some chamfering is going to happen.
For my first step, I'm going to blow the part off. Get some of the cooling off. And then for the second part, we're going to loosen up our vices. Not real wide, just off of the part. Then you'll want to pick your part up. I like to turn it upside down, let all the coolant run out of the screw holes. Get it at an angle, and I go through with the air gun and try to get all the coolant out of my screw holes. Once we get the part blowed off, we'll take it over and set it on the cart for op 2. Alright, so now we're going to unload this part for, get the next part in for op 2. There again, we're going to take our ratchet, eye protection always, take our ratchet and we're going to break it loose. You don't want to go wide on this one. Just enough to see a little gap between there. Then I take my air gun and I blow my coolant off. I'm going to pick it up out of there. We'll blow all the coolant out from under it. Set it over here on the table. Alright, so we got our next part. It's going in for op 2. If you notice, our jaws are going to have coolant on them. We're going to clean them off. They're specially cut for our part. We have to cut the jaws the same way we have to cut the part. I just try to get as much of the coolant off as I can. And it's called a finger wipe. You take your finger and you wipe, make sure there's no chips left on there. If there's any chips left, it'll leave dents and scratches all over your new billet part. So when you set it in, I always like to get a little more at the level. You want to get them straight in there. On this one, I don't know if you can see, there's a line right here. I always try to line that line up. Get it in, and then I always look under the part to ensure that it's all the way down. Then we're going to grab our torque wrench, which I think we keep this one at like 35 foot-pounds. Give that one a little bit. Then I'm going to give this one the full click. Then I'll go back to this one and give it the click. Alright, and then you would shut your door and hit start. Keep your finger on the red button so you know everything's cutting good.
Alright guys, it's time for op 2. Now, I just wanted to show you guys all the tool paths. So everything from adaptive roughing passes to flat facing to chamfering. There's a bunch of tool paths that go into these. Now, basically, we're going to go into a simulation real quick, and I'm going to show you exactly what happens in the finish pass. I'm going to put this thing in fast forward so it doesn't take all day, but I am going to highlight all the tool paths in the simulation so you guys can actually see all of them. Now, these parts are pretty simple. They're only being made on a 3-axis mill. They're not nearly as complex as our 5-axis parts, but I think it's really cool to actually show you guys, I guess, from a raw piece of block to a finished part. So right here, Fusion checks for any issues. And yeah, we're gonna hit go here. So there we go, we're doing a final roughing. I'm just playing around with buttons to show you guys different views. So you can turn the stock off, you can also turn it back on. You can do transparent tools, you can get rid of the tool holder if you want in Fusion. It's pretty cool. It's honestly kind of unlimited. So right here, it's just walking up and adding that nice angle cut. Now it actually leaves a little bit of a staircase, and then we go back with a ball mill and actually smooth everything out to get the nice finish. I worked really hard on speeds and feeds on that to get the texture that I like. And now we're on finish passes. Right there, it's going back and forth with the ball mill. It's basically going to contour that, make it look really nice. I'd say this tool path is about 20 minutes. It's really not too bad. The first stop was about, I'd say, 35 minutes. So yeah, guys, these things do take a little bit of time to make. They're not easy to make. But there it is. Let's see what it looks like in real life. One thing a lot of guys don't really talk about with machining is they don't talk about the chip control and the coolant. So we do a lot of chip control. So once the chips are cut, they're coming out this conveyor. They go into the trash can, and we actually have a bin that these go in. We bring them back to the scrapyard. So we spend hours of our day just with chip control in all the mills. So we're lifting these, dumping them, keeping that under control. We also have to keep our coolant filled. So let's check that out. 55-gallon coolant tank. You guys can see this has a little filter that strains the chips out that get past the conveyor. It's a very, very messy process. We've got to keep this coolant fresh, filled, and clean, because we got to have good coolant to make good parts. So another super important part of this is actually the tooling itself. Now, the tooling is crazy expensive. So just to kind of give you guys a rough idea of what we've got here, we've got a Cat 40 holder with an ER collet. This is actually a cheaper tool holder from Haas. They're pretty affordable, but what's expensive is these end mills. So this is like a $200 end mill. They generally wear out quick on the finished tools because we're trying to get that perfect cut on the side of the part. So this tool right here would be the one that's making the shiny surface on the side. That comes down from the side and does a cleanup pass. Yeah, guys, it's something that not many guys talk about. I mean, it does cost thousands of dollars just to tool up a machine. So this machine here, side mount tool changer that holds 30 tools. All right, let's go check out the finished parts. Once the parts are done, they get inspected. Once they pass the inspection, we put them on the shelf. These are now awaiting assembly. Now this is a key component to our big wheel swing arm. You guys can see it right here. We've got the parts laid out for our swing arm. This is the part we've been talking about in the video. This is the main side of our swing arm. Now we've got a handful of parts that go together from that side rail to this side rail. We've got a center spine, a linkage mount, and then our pivots. Of course, we put the bearings in. We've also got removable chain adjusters. So there's a lot of little bits and bobs that we actually make. Here's the center spine. This gets done in the 5-axis, so it's a little bit more of a complex part than just those side pieces. And yeah, guys, pretty freaking wild what goes into all these parts. Hope you want to learn anything else about CNC, just put it in the comments. If you have any questions, maybe we can make a follow-up video and show you guys some more of the process. All right, guys, thanks for watching. Again, if you have any questions about what you saw today, or you want to see how some of our other products are made, definitely hit me up. We have a hell of a lot of fun making parts for you guys, and I appreciate all the support. We would not be here without you guys. And as we continue, we're going to keep buying more machines like that and making crazier parts. So comment what you want to see us make in the future, and we'll see you guys in the next video.